Thank you. Morning. Thank you all for coming along. Can you hear me okay? Yeah? Great. So I'm Tom. I'm the CEO of Qualinx. We're based in Delft, about an hour south of here. And I'm here to talk about why digital RF matters. Digital RF is the foundational technology, the novelty, and the IP upon which we build all of our GNSS receivers at Qualinx. And you might guess from the subtitle, Big Ideas with a Small Footprint, that it's all about scalability. And that's our core unique advantage that we're hoping to transform the industry through our own products. So I'll talk a little bit about affordable connectivity. And what is affordable connectivity? And that is connectivity that is affordable in terms of power, performance, and total cost of ownership. So if you're from the semiconductor industry, you'll be fully aware of the trade-off between these three things, power, performance, and cost. And there's always at least one that you cannot deliver. And that's one of the breakthroughs that we have at Qualinx. We don't have to sacrifice or trade off any one of those components, that we can deliver power at good performance at good cost. Back in 2011, I was on a project where our company acquired several other businesses, and we were going to build an IoT edge node. And we had logic, we had memory, we had MEM sensors, we even had a harvester, a PMIC harvester, and we were missing connectivity. The only thing available in the market was Dialog's Bluetooth, 55 nanometer Bluetooth, and they wouldn't sell IP. They'd only sell the component. So after a full year trying to put the edge node together, we just gave up because you could not have affordable connectivity. And now, 14 years later, we have it. I'm standing here talking about it. So it's taken a long, long time and a lot of money to get there, but we have what we now believe to be the invisible infrastructure, digital RF. That's how we like to talk about it. Traditional analog RF, the problem with it is that it's bulky, it scales really poorly, it's rigid, and it's power hungry, especially relative to the rest of the digital components as they scale down, and it's protocol bound. Most of our competitors will lock you into maybe 2 or 3 nodes, operating nodes, continuous, and maybe 2 duty cycle low power nodes, and that's it. And then you're protocol bound to the band or the constellation or whatever that is specifically designed to. With digital RF, and with the Qualinx products, we're flexible, efficient, and we're future-proofed. And I'll talk about this in a lot more detail as we roll along, but in contrast to traditional analog, there's no difference. So we have one hardware platform, and from that hardware platform, that single platform, we can provide GNSS, long-range IoT radios, short-range IoT radios without compromise and beyond. In fact, GNSS and IoT are only about 5% of the entire spectrum that our platform can support overall. And what's the result of this? Really, it translates into 3 core value props that we provide to our customers. First and foremost, reconfigurability. That's the DNA of our technology and the DNA of our company, and that's what's most transformative about our technology versus the legacy or the incumbent that's in the industry today. Because we can convert about 80% of an analog radio into a digital CMOS process, we get all those intrinsic benefits. There's intrinsic lower power, the transistor size as it scales down gives you better performance, and the total cost of ownership just continues to follow Moore's law, just like digital. The next one is innovation without reinvention. You design our hardware once, and that's it. And we can regenerate that product lifecycle through software, and it's a future-proofed, backward-compatible, left and right, any which way you want, compatible footprint that we provide going forward. Transformation through efficiency. Because it is CMOS bound and CMOS process, we have intrinsically lower power. We build on GlobalFoundries 22 nanometer process, the SOI process, and with our architecture combined with that process technology, we're able to sustain a 1 milliwatt at 1 hertz duty cycle tracking mode. Our continuous is around sub 6, and most of our competitors are about 6 to 7 milliwatts for continuous. The big difference, and I'll talk about it in a moment, is that we're not bound. We're not locking you into single modes or one continuous and two duty cycles. You can drive the chip any way you want, at any power level and any performance level. The core value proposition for us, the foundational layer, is Moore's Law, essentially, and that means CMOS scaling. And again, if you're from the semiconductor industry, this is sort of table stakes in that business. And as you scale, you get the benefits of miniaturization, integration advantage, and future-proof technology. What I mean by that is we have line of sight to well beyond FinFET and well beyond sub-10 nanometer. And we've proven out these nodes. Most of the industry is at 22. We're probably in leading position at 22. Broadcom has a 7 nano, but it's for mobile specifically, and it doesn't really fit in the use cases that we are addressing in our marketplace. However, our direct competitors in that segment have at best a 28 nano or a 40 nano. Our launch node is 22 nano, and you get all of those benefits and scaling into the future. We do not hit the scale wall. And we do all of this in a 7 square millimeter die. And we have a QFN package, and then we have a chip scale package. Chip scale obviously is at 7.5 square mil. So very, very efficient. So how do we unlock these downstream innovation cycles with the value props that I just outlined and highlighted? Well, extended battery life is the most obvious benefit of adopting our DRF-based GNSS technology. Because the size is so small and because the duty cycle capabilities and power profile is so small and efficient, you can do all sorts of great things with your battery. You can even get rid of it. Once and for all, you can get rid of it and put a harvester in there. And you can do that reliably with the type of power that we drain. Simplified integration. Our chip also includes, it's very integrated insofar as we take a lot of the external bill of materials from a module and integrate them on die. The LNAs, the ADC, the TCXO are just 3 examples of what we take off the chipset, off the board, your motherboard, or the module, and integrate it on die. So we're simplifying your process, your design cycle, and taking cost and complexity out of it. Ultra-compact forms, again, because we're cleaning up the bill of materials that sit around your GNSS, and because we're scaling digitally, you've got a lot more space and a lot less thermal to deal with in your environment. And this, it's in and of itself, generates a lot of innovation in the product. Whether you want to put more battery power in that space or you want to shrink the entire form factor, again, we enable all these options through the technology. And finally, supply chain efficiency. And we quite often overlook the impact on the company's operating expense and so forth, but because you're eliminating components from the PCB and the chipset, and because we have scalability through to sub-10 nano, your supply chain team have a lot of benefits where they themselves, again, can take more cost and more complexity out of managing the business. So, and the benefits of working with Qualinx's DRF, it just doesn't impact the product or the design cycle, it impacts the operations of the company. So the future that we're building, I'll talk about this for a few minutes. It's based on, I'm just going to click through the build. There's a lot of builds in this. So this is how we envision the future that we enable in a very compact form, one slider. The platform innovation, it all starts with DRF. And I think I've spoken about all the true value propositions of DRF for the last few minutes and how that enables quick design cycles and longevity in your roadmap, and security and stability insofar as you will get the same footprint from us through all the shrinks down into single nodes, such as 3 nano, I think we mentioned a while ago. And we build this on 3 core feature sets. Dynamic interference control. The chip itself is really resilient. We have a lot of novelties and a lot of innovation in hardware. And it always reminds me of many years ago, I'll date myself, but I used to support RIM, Research in Motion, the BlackBerry guy, if anyone remembers BlackBerry. And they had a philosophy that the best security was in hardware. And then you pile on software, and that's how you make the device as resilient as possible. And in fact, they made us design a custom 4K byte block in the device just so they could have security at the deepest root in the device. We take the same approach. Security is a function of the hardware features first and foremost, and the resiliency that we have in the device is second to none. Security, anti-spoofing, anti-jamming gets a lot of press today, particularly with all the turmoil around the world. But the classic use case, of course, is multipath mitigation in the urban jungle or where you don't have line of sight or clear skies. And then compound that with all of the geopolitical issues. The challenges of having anti-spoofing and anti-jamming are just getting more and more difficult. Once again, it's what we have rooted in hardware that gives us that advantage and resiliency. And all of this comes as part of the chip. It almost comes for free. And the adaptive intelligence, what we mean by that is because the chip is reconfigurable, you can truly fuse it with the other sensor fusion that you might have in your system. And you can now adapt how you connect in response to those trigger events that your sensor fusion is wired for. You're not locked into just one mode or two modes. It can adapt in real time based on the environment. So we like to think that we're redefining that connected edge. We're giving you a very secure edge and one that's always on at a very affordable rate. And we invite you to come along to our stand, B09, and check out the demo. So I have, I think, 2 minutes for any questions. And if not, we can follow up at the stand. I just want to say thanks for dropping in and listening to our presentation. I hope you know a little bit more now about digital RF and what it might be able to do for your products and your design cycles. Yeah. Hi.
Yeah, just one question. Usually from my experience with software-defined radios and reconfigurable radios, there's one big problem, which is bandwidth, which often requires designing huge RF front-end and filtering on the PCB.
Yeah.
Which ends up being maybe a disadvantage. What kind of specs do you achieve in terms of bandwidth?
Yeah, we have single-sided bandwidth at 60 and double-sided, obviously, at 120. So we think we have plenty of headroom when it comes to the bandwidth issue.
Okay. Also, you said that you end up saving lots of space in PCB components.
Yeah.
But, for example, for applications that don't really need to be reconfigurable, PCB components are always cheaper than ICs, right? Or is that not the case?
It depends on what node you're manufacturing and what your die size is. And in 7.5 millimeters square, we integrate many of those external components. So the unit economics of our die and our production process is such that it will always be cheaper to have that on-die solution than having external components. And you're also eliminating points of failure, and you're cleaning up your supply chain because you're not carrying, so the total cost of ownership does add up, but you have to have the right die size for that to work. Thank you. Good questions. I appreciate them. Thank you. I think that's it for me. Yeah. All right. Well, thank you all very much, and please feel free. B09. Thank you.